welcome to week 4 databases. This week we're going to be talking about some of the differences between a spreadsheet and a database. We're going to be listing some of the main characteristics of a database, and we're going to describe how a database is used differently than a table in a Word document. A lot of what I am going to be focusing on is what is a database. A database is a collection of information. So this database is, or a database, is really useful because it allows us to store and organize data so that we can get to it easier. Databases are really good for larger amounts of data. For example, customer information or products that are being sold in a store, item collection information, or records. So, for example, patient records or student records would be stored in a database because we might be able to store them in something else, for example, a spreadsheet, but that can get really overwhelming really quickly and would also be used for different things than a database would. So, the next thing that we want to talk about is how databases are different than spreadsheets because databases and spreadsheets are not the same thing. Now, both are used to store and organize data. A spreadsheet, a common one is going to be something like Excel or Google Sheets. Spreadsheets are really good for calculations and data entry. So one of the things that you may see is people putting data into a spreadsheet and then taking the data from the spreadsheet program and then sending it to a database. It's because it's really easy to add information into a spreadsheet and get it organized into rows and columns and then get that information into the database from there. Databases are better at manipulating data, running reports, and updating data. Databases are really good at doing things like asking questions, not mathematical manipulation. So, like for example, Excel might be really good at doing mathematical manipulations of records that are going to be calculations that we need to do. You're going to see a lot of functions are some variety of math. Databases allow us to ask questions about the data in a different way and also give us results that are going to look a lot different. Databases are also great if there's multiple people that need access, because if we have one person that is viewing and adding data to, for example, a spreadsheet, that isn't that bad. However, in a lot of real life scenarios, it is not just a single person adding, removing, or accessing data. It's actually a lot of people, and a lot of places around the company will need access to that data for different things. Databases are a lot better at being able to handle that kind of access. But very importantly, spreadsheets are not databases. The thing they have in common is that they can both store and organize data, but fundamentally, they are not the same thing. When we have our data that is being put in our database, we might have structured data or unstructured data. Structured data is going to be organized and formatted. Unstructured data is not. Now, if you haven't heard of version control before, version control is the ability to be able to see the edits that we've done to the thing that we're working with. For example, programmers will really commonly use version control on their programs because it gives us the ability to see the previous versions of what we've tried. So instead of needing to have, for example, 5 functions all in a list, it's like if you were writing an English paper. Instead of having the same paragraph 5 times with only minor changes, we would be able to make the change and then save it to our version control software and add a commit message, which basically says why that change was made. And we would be able to go back through the entire history of all of the changes and edits that we've made to be able to make sure that we can see what was changed, who changed it, when they changed it and why they changed it. So that version control can be applied over parts of the data if it's structured data, or it can be done in different ways. Whereas unstructured data, version control only happens over the whole of the data. Structured data allows queries of different types. Unstructured data only allows text-based queries. Structured data tends to be more quantitative and is formatting in ways to be more readable for humans. It's easier for us to be able to run machine learning algorithms on it, and it's easier for people to manipulate and analyze the data without needing to go as much into data types. Structured data is generally found in spreadsheets and databases. Now, a CSV, or comma separated value. When we end up wanting to, for example, move data between programs, let's say we are card collectors and we play Magic the Gathering. If you haven't heard of Magic the Gathering or Pokemon or Yu-Gi-Oh, I guess I would say probably don't research it because it's a bit of a time and a money sink, but basically there's a whole bunch of different cards that have different values, and it's important to keep track of the cards that you have so that you can build a deck correctly for different scenarios and probably have different decks because it's a rabbit hole that hypothetically nobody here would have fallen down. Anyways, so let's say, for example, we are saving our data about our magic cards. And so we would have the name of the card, the type of card it is, the value of the card, and which deck or decks it would be a part of. If I have a comma separated value, I would be able to take that data and move it into a spreadsheet or move it into a database or save it as a comma separated value and move it between those programs really easily. Now, it doesn't necessarily have to be commas, so this is a very literal like card, comma, value, comma, type, comma type of thing. You could also use spaces, semicolons, other things can be used as what's called a delimiter. A delimiter is the type of punctuation that is used to indicate that a new value is coming. So CSV is also not proprietary, which means that it's good for using between multiple programs that might use proprietary data. So if you're going from like one database to another database, CSVs would give us the ability to do that. Databases allow us to store data more easily and organize the data differently. When we have data organized in our database, it allows us to run reports better. So, for example, let's say I have a customer database and a product database. I would be able to say things like, what is the email address for a specific customer? Or what are all of the email addresses for customers that have made purchases in the last 6 months or a year? I could ask things like, what units were sold last month or last year? How much of a product was sold? And those are the types of questions or queries I would be able to ask our database. Database will also allow multiple people to ask that. So like if, for example, I had a customer database and a sales database, and I worked in sales, I could say who has made purchases in the last month. And then I could say, maybe these are the people that I want to go talk to again, or maybe they've made their purchases and I don't need to go talk to them again. But I could also have, for example, customer service accessing the same database and say, hey, what's the email address of customers that have made a purchase in the last week? We'd like to ask them for a review. And so two different people or two different departments might want to ask questions of our customer database at the same time. And databases give us the ability to have that happen. Centralized locations for the data also makes it so that the data that we're accessing is likely to be more accurate. And so that's going to allow, for example, the multiple people that are trying to ask questions of the database get the best answers. If you're working off of an old customer database and it hasn't processed anybody in the last 6 months, that's not going to be as useful for anybody. Whereas if you had, for example, two databases and you had both sales and customer service having their own databases instead of a centralized database, they would both have to update it. They would both have to do the work of maintaining it. They would both have to do the work of checking the data accuracy. And they are unlikely to get it right all the time. So, different types of databases. Now, databases are organized in different ways, and it's basically how the different pieces of data are being stored. One of the most common types of databases that we'll have is what's called a relational database. That's where we're going to be focusing because it tends to be relatively commonly used. You are very likely to see one if you're going to be working with databases, and it's a lot easier to find one that is, quite frankly, free. So that's why we're going to be picking that. However, there are absolutely other kinds of databases. We could have object-oriented databases, hierarchical databases, and all that changes is how the data is being organized and saved. A relational database specifically organizes data into rows and columns to form tables. That's going to look very similar to the spreadsheets that you've probably seen before. The data is going to be structured on multiple tables. So what's going to end up happening is we are actually going to be saving all of our data, likely in multiple tables, and when we ask questions about our data, we're going to ask questions of a specific table or several specific tables. Tables are connected or relate to each other using different types of keys. Multiple relationships or connections between the tables are possible. For example, if you have a table of customers, a table of products, and a table of sales, you would be able to ask assuming you keep this data, you would be able to ask something like, who has purchased pencils in the last 6 months? Please give me their email addresses. And I could pull that information from all of these tables by taking our sales, seeing how it relates to products, and then seeing how those relate to customers. So we would be able to get the email address of everybody who has placed an order for pencils, which pencils they got in the last 6 months. When we are talking about databases, we are going to be using something called SQL. SQL, or Structured Query Language, is how we are going to be asking questions of our database. So all of these tables that we were talking about and those questions that we were asking, I can't just sit in front of my computer and yell questions like, who made purchases last month? The computer is not going to help me for that. If I use SQL or SQL, depending on who you ask, I would be able to formulate those questions in a way the database would be able to understand. SQL is the query language that we're using to ask questions. MySQL is one of the ways that we could write a database. That's the database. As a note, there are multiple versions of SQL, which we'll talk about later. There are multiple versions of databases. MySQL is not the only relational database. That's just one of the common ones that you're going to end up seeing. You may see SQL being pronounced as SQL. You may see it as being pronounced SQL. I tend to pronounce it SQL, but either one could be considered correct. However, as a warning, you are going to run into people that are going to have very specific opinions on this. It may or may not be worth arguing to you. That's up to you. That is the end of our introduction to databases. We will be talking about some more database vocabulary in the next week. I hope you are all having a lovely day.